bit. Zero. So, how are we going to get this thing off the ground? We're going to fire 2 sets of motors to get this thing as high as we can. We're going to fire an Aerotech L1420 rocket motor followed by an Aerotech K750. This will reach us to an altitude greater than 9,000 feet, carrying around 60 golf balls as high as we can. To ignite the second stage, we fashioned our own igniter using a combination of Blue Thunder rocket propellant and an MLG firewire initiator. This is due to the voltage requirements required to light a rocket motor. To ensure that we can stage successfully, we must follow 3 rules: altitude, velocity, and orientation. Controlling all of this is our featherweight Blue Raven flight computer. This flight computer has a barometric sensor to tell how high it is, an inertial measurement unit to tell orientation, and is capable of lighting multiple ignition systems, whether it's recovery or ignition. Our backup flight computer on this flight will be a Egg Timer Quantum flight computer. This computer is quite flight proven. I've flown it myself, and it is capable of firing 2 charges. That is a drogue charge and a main charge. Next, let's talk recovery. Our first stage is equipped with 1 parachute. This is a 30-inch diameter parachute, and our second stage is equipped with 2 parachutes, a 77-inch main parachute followed by a 20-inch drogue parachute. Our drogue chute is about 1/4 the size of our main parachute, and our main parachute ensures that we touch down at a velocity less than 35 feet per second. For the deployment of our parachutes, we're going to be using a series of charge wells that we have proven in the past with aluminum 661 charge wells. On this flight, we're going to be using ABS 3D printed charge wells. These charge wells we have already tested, and each charge well is going to be loaded with about 5 grams of gunpowder or black powder. Within these charge wells is going to be an MLG firewire initiator. These charge wells will then be topped off with a piece of aluminum tape, ensuring that the charges build up enough pressure before bursting, allowing for the airframe to be filled with pressure, therefore deploying our parachutes. The nose cone of our second stage, as well as the upper airframe of our second stage, is secured to our lower airframe with a series of 3 440 shear pins. Each shear pin is designed to break at a maximum of about 75 pounds of force, so if you do some quick math, that will be a total of around 300. We won't go into that. In the second stage of our 2-stage rocket, we have fabricated a forward bulkhead which can be bolted in place that will secure 30 golf balls in the lower airframe of our second stage. This is also where our primary recovery system for our second stage attaches to, in the form of a wire harness, a swivel, and a bunch of quick links. In the nose cone of our second stage are the remainder of the approximately 30 golf balls. This is where we have more golf balls loaded into the rocket. The nose cone is secured to its shoulder with a series of plastic rivets, capable of carrying roughly 60 golf balls. We have a 77-inch main parachute in our upper stage right here, and this uses a standard dual deploy configuration with a 30-inch drogue here. The way we calculated the size of the drogue parachute is that the size of the drogue parachute roughly is 1/4 the size of the main. This ensures that we come down reasonably quickly and we don't go ballistic on the way down. Here we have our first stage. Our first stage is fairly small. I should say that this is built out of a Wildman Rocketry Argonia Cup kit, so designed specifically for the competition. This parachute in here is actually fairly small. It's a 30-inch main, mainly because the first stage is actually fairly light, and so we estimate it'll come down pretty quickly. But the last thing to mention here is that in here we'll have a separation charge for redundant separation. There's a really good quote by Peter J. Beck of Rocket Lab that says, "Make everything you do look beautiful." The livery of our 2-stage rocket was designed by a friend in Ireland, in which it incorporates both the UC Merced colors as well as the colors of AIAA, creating a striking and bold aesthetic for our rocket. With that being said, that is everything about our rocket for the Argonia Cup competition in 2024. We look forward to competing in the Argonia Cup in Kansas, and we'll see you there.